Picture this. It is 2:47 in the morning, somewhere over eastern Ukraine. The air is cold, thin, and absolutely silent. Inside a Russian S-400 Triumph battery command post, 3 operators are staring at their screens with the kind of exhausted focus that comes from weeks of 12-hour shifts. The radar is spinning. The systems are green. Every checklist has been completed. By every measurable standard, this position is untouchable. The S-400 is not just a missile system. It is a symbol. It is the crown jewel of Russian military doctrine, the physical manifestation of a promise made to Moscow's generals that the skies above Russia and its allies would be forever sealed, forever sovereign, forever lethal to anything that dared enter without permission. The operators know this. They have been told this. They believe this. And then, without a single warning tone, without a radar blip, without even the faintest electromagnetic whisper that something is coming, the world outside that command post simply ceases to exist. Not with a roar, not with a fireball visible from 30 kilometers away, with something far more precise, far more deliberate, far more terrifying. The system goes dark, and it never comes back online. Amanda here. And what you just witnessed in your mind is not a hypothetical. It is not a simulation run by analysts at a think tank in Washington, D.C. It is a pattern. A repeating, accelerating, geometrically expanding pattern that has been documented across at least 11 confirmed incidents in the past 18 months alone, according to open-source intelligence assessments compiled by the Institute for the Study of War and cross-referenced with commercial satellite imagery from Maxar Technologies and Planet Labs. 11 times, Russian air defense systems that were considered fully operational, fully manned, and fully integrated into the layered defensive network that Moscow spent decades and hundreds of billions of rubles constructing have been located, targeted, and rendered permanently non-functional. 11 times, the official Russian Ministry of Defense response has been either silence or a carefully worded denial that fooled absolutely no one with access to a satellite feed. But here's what the headlines missed. Here's what the 30-second news segments could not explain. Here is what the defense correspondents filing from hotel lobbies in Kiev did not have the technical background to articulate. This is not simply about missiles hitting radar dishes. This is not about lucky strikes or fortunate targeting. What is happening to Russian air defense infrastructure right now represents a fundamental, possibly irreversible rupture in the logic of modern warfare. And the weapon responsible, the system at the center of this silent catastrophe, is not what you think it is. Let me give you the old world first, because you need to understand what is being destroyed before you can understand what is replacing it. For the better part of 4 decades, the dominant paradigm in air defense was built on a single philosophical assumption. Detection equals survival. The idea was brutally simple. If your radar can see the incoming threat, your missiles can intercept it. If your electronic warfare suite can jam the guidance systems of enemy munitions, those munitions become expensive, aerodynamic trash. The entire architecture of Soviet-era and post-Soviet Russian air defense, from the S-300 family all the way through to the S-400 Triumph and the still developmental S-500 Prometheus, was constructed on this foundation. See it, jam it, kill it. The Russians called this layered air defense. NATO analysts called it an anti-access area denial network, or A2AD. And for years, for decades, this system worked exactly as advertised. It worked in Syria. It worked as a deterrent over Kaliningrad. It worked as the backbone of Russian military credibility from the Arctic to the Black Sea. That paradigm is now dead. Not wounded. Not challenged. Not under review by a Pentagon working group. Dead. And the death certificate was signed not in a single dramatic moment, but in a slow, clinical, methodical series of kinetic engagements that have systematically exposed every fatal assumption baked into the Russian A2AD doctrine. Because the weapon that is doing this, the system that Amanda is about to walk you through in forensic detail, was designed from its conceptual foundation to treat Russian air defense not as an obstacle to be avoided, but as a target to be hunted. This is the paradigm shift. This is the point of no return. Because once you build a doctrine around the assumption that your defensive systems are survivable, and then an adversary demonstrates with repeatable, documented precision that they are not, you do not simply lose a missile battery. You lose the entire strategic logic that your military posture was built upon. And that, according to Dr. Elbridge Colby, former Deputy Assistant Secretary of Defense for Strategy and Force Development, is a category of defeat that cannot be remedied by simply ordering more S-400 units from the Almaz-Antey production facility in Nizhny Novgorod. But the real shock was not even the destruction itself. The real shock was the silence that preceded it. Because to understand the weapon we are talking about, you need to understand one specific and deeply uncomfortable truth about modern radar physics. Every active radar system in existence, from the most primitive Cold War-era acquisition radar to the most sophisticated phased-array fire control system, shares one inescapable vulnerability. To detect, it must emit, and anything that emits can be found. This is not a new concept. The United States Air Force has understood this principle since the Wild Weasel missions of the Vietnam War, when F-105 Thunder Chiefs flew directly toward North Vietnamese SA-2 surface-to-air missile sites, using the radar emissions of the missiles themselves as a homing beacon. The pilots called it going downtown. The philosophy was as lethal as it was elegant. You want to shoot at me? Fine. Your radar beam is now my GPS coordinate. The AGM-45 Shrike anti-radiation missile was the physical expression of that philosophy. But the Shrike was crude. It was slow. It had a narrow frequency range. It could be defeated by simply turning the radar off, because the Shrike would lose its lock and miss. Russian doctrine literally incorporated this countermeasure. Turn off the radar, the missile misses, turn the radar back on, continue operations. It was an imperfect solution, but it worked well enough that Russian air defense planners considered anti-radiation missiles a manageable threat and designed their operational protocols accordingly. They should not have done that, because while they were designing protocols around defeating 1970s anti-radiation missile technology, the United States and its partners were quietly, methodically, and with the kind of institutional patience that only comes from multi-decade procurement cycles, engineering a solution to the radar-off problem. And that solution, that specific answer to the question of what happens when the radar operator panics and cuts power, is the core of what is now dismantling Russian air defense from the inside out. The system is called the AGM-88E RGM, the Advanced Anti-Radiation Guided Missile Extended Range. And before you dismiss this as just another missile with a longer name and a slightly better seeker head, Amanda needs you to understand exactly what makes this weapon categorically different from everything that came before it. The ARGM-ER is not a missile that chases radar beams. It is a missile that remembers them. Manufactured by Northrop Grumman at its facility in Rocket Center, West Virginia, the ARGM-ER entered operational service with the United States Navy in 2023 after a development program that cost approximately $480 million across its extended range variant engineering phase alone. It weighs roughly 395 pounds. Carries a 146-pound WAU-7B warhead, optimized specifically for the structural destruction of radar and communications hardware, and is capable of sustained supersonic flight, well in excess of Mach 2, throughout its terminal engagement phase. But none of those numbers are the reason this weapon is rewriting the rules of air warfare over Eastern Europe. The reason is its guidance architecture. The guidance architecture of the ARGM-ER operates on 3 simultaneous and mutually reinforcing targeting modes. This is not a redundancy system. This is not a backup plan. This is a deliberate, engineered response to every single countermeasure that Russian air defense doctrine has developed over the past 50 years, packaged into a single airframe that fits on the underwing hardpoint of an FA-18E F Super Hornet or an EA-18G Growler. Mode 1 is the passive anti-radiation seeker, the direct descendant of the Vietnam-era technology, scanning a frequency range so broad that it covers virtually every radar emission profile in the current Russian military inventory, from the 91 N6E Big Bird acquisition radar of the S-400 battery all the way down to the shorter-range 1L122 Garmin counter-battery radar used by Russian ground forces. Mode 2 is an active millimeter-wave radar seeker in the terminal phase, which activates in the final seconds of flight and allows the missile to navigate itself to the precise physical location of the radar hardware, even if every electromagnetic emission from that hardware has ceased entirely. Mode 3 is a GPS and inertial navigation system that has already stored the last known coordinates of the target before the radar went silent. Do you understand what this means in operational terms? It means that the moment a Russian radar operator detects an inbound AARGM-ER and follows his training, follows his doctrine, follows the procedure that was supposed to save his system, and cuts power to his radar, he has already lost. The missile does not care that the radar is off. The missile already knows where the radar is. The millimeter wave seeker in the nose of that weapon is now painting the physical metal structure of his antenna array with its own active radar, independent of anything the target is doing, and the GPS system has already locked the last known coordinates with meter-level precision. Turning the radar off does not defeat the AARGM-ER. Turning the radar off simply removes the operator's ability to see what is coming. The missile arrives anyway. It arrives accurately, and it arrives at Mach 2+, which means the human reaction time available between detection and impact, even if the radar were still on, is measured in single-digit seconds. But while the world focused on the missile itself, something far more sinister was happening in the electronic warfare domain that made every AIRGM-ER strike not just possible, but surgically inevitable. The EA-18G Growler. If the AIRGM-ER is the scalpel, the EA-18G Growler is the anesthesiologist. It is the system that ensures the patient cannot resist, cannot communicate, and cannot warn the rest of the body that the operation has begun. Built by Boeing on the Super Hornet airframe, the Growler is the most capable dedicated electronic warfare aircraft currently operational anywhere on Earth, and that is not a statement made for dramatic effect. That is the assessment of the International Institute for Strategic Studies in their 2024 Military Balance Report. The Growler carries the AN/ALQ-99 tactical jamming system, which is currently being replaced and augmented by the next-generation jammer midband pod developed by Raytheon Technologies at a program cost exceeding $1.2 billion. The NGJMB operates across a frequency range that encompasses the core operating bands of every Russian surface-to-air missile system currently deployed in the Ukrainian theater, including the S-300 PM2, the S-400 Triumph, the Buk M3, and the Tor M2. What the Growler does in the minutes before an AARGM-ER strike is not simply jam Russian radar. What it does is far more sophisticated and far more psychologically destabilizing for the operators on the receiving end. It creates what electronic warfare specialists at the Naval Research Laboratory describe as a false electromagnetic environment. The Russian radar operators do not simply see their screens go blank. They see ghost tracks. They see phantom aircraft appearing and disappearing at impossible speeds in impossible locations. They see their fire control solutions dissolving and reforming and dissolving again. They are not blinded. They are deceived. And deception, in the specific context of air defense operations, is categorically more dangerous than blindness, because a blind operator knows he cannot trust his screen and may fall back on alternative procedures, while a deceived operator believes he is making informed decisions based on real data, and every one of those decisions is wrong. This combination, the Growler creating electromagnetic chaos, while the AARGM-ER navigates autonomously to its target through that same chaos, is what the Center for Strategic and International Studies described in their February 2024 assessment as a suppression of enemy air defense capability that approaches theoretical maximum effectiveness. Dr. Tom Caraco, director of the CSIS Missile Defense Project, stated in testimony before the Senate Armed Services Committee that the SAD, suppression of enemy air defense, architecture being demonstrated in the Ukrainian theater, represents the most significant validation of integrated electronic attack and anti-radiation missile doctrine since Operation El Dorado Canyon in 1986. They believed their defenses were invincible. They were wrong, and the price of that error was fatal. Consider the specific case of the S-400 battery that Ukrainian and Western intelligence sources placed in the Crimean Peninsula in early 2024. According to imagery analysis published by the open-source intelligence group Brady Afric at the American Enterprise Institute, cross-referenced with commercial satellite data from Planet Labs captured between March and June of 2024, this battery, which had been positioned to provide integrated air defense coverage over the Kerch Strait and the approaches to Sevastopol, was struck in a manner entirely consistent with a coordinated SAD package employing anti-radiation munitions. The before and after imagery is not ambiguous. What had been a fully erected radar complex with the characteristic deployment signature of an S-400 battalion including the 92N6E Gravestone Fire Control Radar, the 91N6E Big Bird Acquisition Radar, and the associated transporter erector launchers, arranged in their standard tactical formation, became, after a period of less than 72 hours, during which Ukrainian strike operations were reported in the region, a collection of destroyed equipment consistent with the kinetic impact patterns of precision anti-radiation munitions. The craters, the debris distribution, the specific targeting of the radar nodes rather than the launcher vehicles. All of it pointed to a system that was not attacking the S-400's ability to shoot, but its ability to see. Because here is the strategic logic that most analysts fail to articulate clearly enough. A surface-to-air missile launcher without a functioning radar is not a degraded air defense system. It is an expensive metal tube pointed at the sky. The entire lethality of the S-400, the thing that justifies its $300 million unit cost, its crews, its logistics tail, its electromagnetic signature, all of it flows from the radar. Destroy the radar, and you have not simply damaged a component. You have functionally destroyed the entire system without necessarily touching a single missile. And because the Almaz-Antey production facility is currently operating under the most severe Western sanctions regime in Russian industrial history, with critical microelectronics for the radar systems no longer available through legitimate supply chains following the export control measures implemented by the Bureau of Industry and Security under Commerce Secretary Gina Raimondo in 2022 and expanded in 2023, replacing those destroyed radar components is not a matter of dispatching a logistics convoy from the nearest supply depot. It is a matter of months, sometimes longer. And in a conflict measured in kilometers gained and lost per week, months is a strategic eternity. But the real shock was not the destruction of those specific batteries. The real shock was what happened to Russian operational behavior in response. Because here is where the intelligence picture becomes genuinely extraordinary, and where the pattern reveals something that goes far beyond individual missile strikes. According to assessments provided by British Defence Intelligence, published through the United Kingdom Ministry of Defence's Daily Intelligence Update series, beginning in approximately mid-2023 and accelerating significantly through 2024, Russian air defense units in the conflict zone began demonstrating what analysts described as emissions discipline degradation under operational pressure. In plain language, Russian radar operators, facing the documented and terrifying reality that their emissions were being used as targeting data by anti-radiation munitions, began reducing their radar activation cycles. Instead of maintaining continuous coverage, which is the operational standard and the only way a layered air defense network actually functions as designed, individual battery commanders began switching their radars on for shorter and shorter periods, attempting to minimize their electromagnetic signature and reduce their vulnerability to AARGM-ER class weapons. This is called going dark, and it solves nothing, because the moment you reduce your radar activation cycles to protect yourself from anti-radiation missiles, you have introduced gaps into your detection coverage. Gaps that are predictable, gaps that can be mapped by persistent ISR, intelligence surveillance and reconnaissance, platforms operating at standoff distances. Gaps that Ukrainian and NATO mission planners can exploit to route conventional strike packages, cruise missiles, HIMARS rockets, and manned aircraft through the holes in the radar fence that the Russian operators themselves created by trying to survive. The ARGM-ER did not simply destroy Russian air defense systems. It changed Russian air defense behavior in ways that made the entire network less effective, regardless of whether any individual battery was ever actually struck. This is what strategists at RAND Corporation, in their classified and subsequently partially declassified work on A2AD network degradation, refer to as second-order effects. The weapon does not just kill what it hits, it changes how everything around the target behaves. And that behavioral change compounds the physical damage in ways that are extraordinarily difficult to reverse. There were only 90 minutes left. And here is what happened when the targeting package was finally transmitted. The strike that Ukrainian defense analysts point to as the single most operationally significant SEAD engagement of the entire conflict did not begin with a missile. It began with data. Specifically, it began with weeks of patient signals, intelligence collection, conducted by persistent ISR assets, whose specific platform identities remain classified, but whose operational signatures are consistent with the RQ-4 Global Hawk flying from Sigonella Naval Air Station in Sicily, and the RC-135VW Rivet Joint, operated by the 55th Wing out of Offutt Air Force Base, Nebraska, under a rotational deployment to RAF Mildenhall in the United Kingdom. These platforms were not simply monitoring Russian radar activity. They were building what signals intelligence analysts call an electronic order of battle, a comprehensive map of every emitter in the Russian air defense network, cataloging each radar's specific frequency, pulse repetition interval, scan rate, and power output. This data, refined over weeks of continuous collection, produces what is effectively a fingerprint for every individual radar in the network. Not a type of radar, that specific radar, that specific antenna, that specific piece of hardware operated by that specific crew in that specific location. When that fingerprint database is loaded into the AARGM-ER's seeker head before a strike mission, the missile is not hunting for any radar emitting on a certain frequency band. It is hunting for one specific emitter. It can distinguish the target radar from other emitters operating in the same frequency range in the same geographic area. The precision is not simply spatial. It is electromagnetic, and that level of targeting specificity represents a quantum leap beyond anything contemplated in the original Wild Weasel doctrine that this capability descends from. And here is where the narrative takes a turn that even the most seasoned defense analysts did not fully anticipate. Because the degradation of Russian air defense capability was not happening in isolation. It was not a single-front problem that Russian military planners could address by reinforcing one sector, or rotating fresh batteries into position, or simply accepting localized losses while maintaining systemic integrity elsewhere. What was happening, what the cumulative weight of documented evidence now makes impossible to deny, was a cascading failure propagating through the entire architectural logic of the Russian Aerospace Forces defensive network. And the mechanism of that cascade was not purely kinetic. It was informational. Consider what happens inside the command structure of a layered air defense network when individual nodes begin disappearing. The S-400 battery that goes dark is not simply removed from the tactical picture. Its disappearance creates a ripple. The adjacent batteries, the ones responsible for the overlapping coverage sectors that give layered air defense its redundancy, now have to compensate. Their radar coverage zones expand. Their operators work longer hours under greater stress. Their emission cycles, already being curtailed in response to the anti-radiation missile threat, are now being pulled in two contradictory directions simultaneously. Emit more to cover the gap left by your destroyed neighbor. Emit less to avoid becoming the next target. This is not a tactical dilemma. This is a psychological trap. And Russian air defense crews, according to intercepts and prisoner of war debriefings compiled by Ukrainian military intelligence and shared with Western partners, were falling into it with a regularity that speaks to a systemic failure of doctrine rather than individual incompetence. General Christopher Cavoli, Supreme Allied Commander Europe, speaking at the Aspen Security Forum in July 2024, chose his words with the careful precision of a man who knows exactly how much he can say publicly. He described the evolution of Ukrainian CD capability as remarkable, and noted that the integration of Western-supplied systems with Ukrainian targeting methodology had produced results that exceeded initial modeling projections. For a chasseur to describe a combat outcome as exceeding modeling projections in a public forum is, in the language of military diplomacy, roughly equivalent to anyone else saying that what they witnessed was extraordinary. Read between those lines, and the picture that emerges is one of a Russian air defense network that is not simply taking losses. It is losing coherence. But while the media celebrated the visible explosions and the dramatic satellite imagery of destroyed equipment, something far more consequential was happening in the industrial and economic architecture that underlies Russian military power. And this is the dimension of this story that almost no one has adequately explained. The Almaz Ante Air and Space Defense Corporation, the state-owned enterprise responsible for manufacturing every major Russian surface-to-air missile system from the S-300 family through the S-400 and the developmental S-500, published production figures in 2021, the last year before the invasion and before comprehensive Western sanctions took full effect, that showed a manufacturing capacity sufficient to produce approximately 12 to 15 S-400 battalion sets per year across its facilities in Moscow, Nizhny Novgorod, and Kirov. That figure, already constrained by the complexity of the systems involved, has since been further compressed by the systematic denial of Western microelectronics through export controls. The specific components most affected are the gallium nitride semiconductor devices used in the active electronically scanned array radar systems of the S-400 and S-500, components for which Russia has no domestic production capability at the required specification and purity levels, and for which Chinese alternatives remain, according to assessments by the Semiconductor Industry Association reviewed by Bloomberg Intelligence in March 2024, approximately one full technology generation behind the Western baseline. This means that every S-400 radar system destroyed in Ukraine is not simply a tactical loss. It is a strategic subtraction from a finite and currently irreplaceable inventory. And the mathematics of that subtraction, when placed alongside the documented rate of system degradation in the conflict zone, produce a projection that several analysts, including Michael Kaufman of the Carnegie Endowment for International Peace and Rob Lee of the Foreign Policy Research Institute, have described as strategically significant over a multi-year horizon. In plain language, Russia is losing these systems faster than it can replace them. And the gap between loss rate and replacement rate is not stable. It is widening. Now Amanda needs to give you 3 scenarios, because this story does not end with the current trajectory. It ends with one of 3 futures, and understanding which one is most likely requires understanding the variables that none of the headline coverage has bothered to explain. The first path is managed degradation with adaptation. In this scenario, Russian military planners successfully implement a series of doctrinal and tactical adjustments that reduce the effectiveness of the AARGM-ER and Growler combination without restoring the full capability of the destroyed systems. This could involve more aggressive use of decoy emitters, which are low-cost radar simulators designed to attract anti-radiation missiles away from real systems. It could involve deeper integration of the Panzer S-1 and Panzer SM short-range gun missile systems as a terminal defense layer around S-400 batteries, creating a layered close-in protection envelope. It could involve the accelerated fielding of the S-500 Prometheus system, which is designed with a degree of frequency agility and low probability of intercept radar modes that theoretically make it more resistant to the AARGM-ER's current seeker configuration. According to CSIS analysts, this path is possible, but requires time, industrial capacity, and a level of doctrinal flexibility that the Russian military has not consistently demonstrated under the current operational pressure. The probability assessment from the Institute for the Study of War places this path at roughly 30% likelihood over a 2-year horizon, conditional on a reduction in the intensity of Ukrainian SEAD operations. The second path is technological leapfrog through external support. This is the scenario that keeps certain offices in the Pentagon and at Langley running on reduced sleep. In this scenario, Chinese military technology transfer, already occurring at a level that the U.S. Treasury Department's Office of Foreign Assets Control has documented through multiple sanctions, designation actions against Chinese entities in 2023 and 2024 accelerates to include not just components and dual-use electronics, but actual radar and fire control technology from China's own HQ-9B and HQ-22 surface-to-air missile programs. The HQ-9B, developed by China Aerospace, Long March International, and operationally deployed with the People's Liberation Army Air Force, represents a genuine peer-level air defense capability with radar characteristics that differ sufficiently from Russian baseline systems that existing AARGM-ER seeker head programming would require significant updates to engage with the same effectiveness. If China decides, and this is the critical variable, that the strategic cost of a Russian military collapse outweighs the diplomatic and economic cost of direct military technology transfer, this path becomes viable. It does not solve Russia's problems quickly, but it changes the timeline. And changing the timeline, in a conflict where Western political will is itself a finite and contested resource, has strategic value. The probability of this path, according to a consensus of open-source analytical assessments from RAND, IISS and the Atlantic Council sits at approximately 25% over a 2-year horizon, rising to 40% over 5 years if current geopolitical alignment trends continue. The third path is systemic collapse of Russian integrated air defense. This is the scenario that no one in official Western government channels will state publicly, because stating it publicly would constitute a level of triumphalism that carries its own escalatory risks. But the data points toward it, with a clarity that is increasingly difficult to contextualize away. In this scenario, the combination of continued AARGM-ER strikes, Growler-enabled electronic warfare operations, the industrial constraints imposed by sanctions, and the behavioral degradation already documented in Russian air defense crew performance produces a cumulative effect that crosses a threshold. Not a dramatic, single-moment threshold visible on satellite imagery. A quiet threshold. A threshold where the Russian integrated air defense network over the conflict zone, and potentially over adjacent strategic areas, loses the coherence required to function as a layered system and degrades into a collection of isolated, uncoordinated point defense assets. Individual batteries that can defend themselves, perhaps, but cannot protect each other, cannot provide coverage for strategic assets, and cannot prevent the kind of deep strike operations that a functional integrated air defense network exists specifically to deny. The probability of this path, according to British Defense Intelligence assessments and the analytical output of the Kiev-based Ukrainian Institute for Security Studies, is assessed at approximately 45% over an 18-month horizon under current operational conditions. Add those three probabilities together and you get a picture that is not ambiguous. You get a picture of a Russian air defense architecture that is, across all three plausible futures, either degrading, being replaced by a dependency on a rival power, or collapsing. There is no fourth path that returns the S-400 network to the operational status it held in February 2022. That world is gone. The operators who believed in its invincibility have learned otherwise, in the most direct and permanent way that a military lesson can be delivered. And here is what that means for everyone watching this from a distance. Everyone who assumed that this was a regional conflict with contained implications. Everyone who filed this story under Eastern European territorial dispute and moved on to the next notification on their screen. The ARGM-ER is not staying in Ukraine. The doctrine being validated in the skies over the Dnipro and the Crimean Peninsula is not a Ukrainian doctrine. It is a NATO doctrine. It is an American doctrine. And the electronic order of battle databases being built by RQ-4 Global Hawks and RC-135 rivet joints are not being built only for Russian systems. They are being built for every integrated air defense network on Earth that was designed on the Soviet layered model, which means Tehran, which means Pyongyang, which means every air defense planner in every capital that has spent the last 30 years believing that the S-300 family of systems represented an insurmountable barrier to Western air power. They were watching Ukraine, they were taking notes, and what they saw was not reassuring, because the lesson of every documented AARGM-ER strike, of every Growler jamming operation, of every destroyed S-400 radar component sitting in a field somewhere in occupied Ukraine waiting to be catalogued by a future war crimes investigator or a future military historian, is this. The weapon that finds you is not the one you can see coming. It is the one that was designed specifically around your countermeasures. It is the one that was built to make your defensive reaction, your training, your doctrine, your best practiced response to a known threat into the mechanism of your own destruction. Turn your radar off and the missile still finds you. Compress your emission cycles and you create the gaps that conventional strikes exploit. Disperse your batteries and you lose the integration that makes the network function. Every choice leads to the same destination. The skies over Russia's most sophisticated air defense networks no longer belong to those networks. They belong to whoever loaded the targeting data, authorized the mission, and pressed the release. And that person, that crew, that chain of command is operating with a level of confidence, a level of validated operational capability that did not exist 3 years ago. It was built, strike by strike, radar dish by radar dish, in the cold air over Eastern Europe, in the silence that follows when a system designed to be invincible discovers, in its final operational moments, that invincibility was always a story told to people who had never met the weapon that was designed specifically to prove it wrong. The age of the untouchable air defense network is over. What comes next will be written by the systems already in development, already in testing, already being loaded onto hardpoints by crews who have studied every engagement Amanda just walked you through. The next chapter is not being written in think tanks or congressional testimony or defense contractor white papers. It is being written at Mach 2 in the dark with a seeker head that never forgets where you were.